Earthquakes are striking somewhere on Earth almost every hour. But this week, the number of reports has made many people wonder a frightening question. Is our planet becoming more dangerous? Stay with me until the end, because one scientific fact completely changes the way most people think about earthquake activity. Over the past several days, earthquake monitoring networks have recorded dozens of moderate and strong earthquakes across different parts of the world. Activity has appeared in the Pacific Ring of Fire, around Indonesia, Alaska, Japan, South America, and several other active plate boundaries. At first glance, the global map looks alarming. Red and yellow markers seem to cover entire regions. But does that really mean earthquakes are suddenly increasing? One event that caught international attention happened in Qinghai Province, China. Two earthquakes struck only 18 minutes apart. The first measured magnitude 5.7. The second reached magnitude 5.8. Both occurred at a shallow depth of about 10 kilometers. The shaking was strong enough to send dust falling from rocky cliffs and was felt hundreds of kilometers away. Fortunately, there were no immediate reports of major casualties. Events like this naturally raise concern. Social media quickly fills with dramatic claims. Some people say a chain reaction has begun. Others believe a massive global earthquake is about to happen. But seismologists urge caution before jumping to conclusions. The Earth is never truly quiet. Every single day, our planet experiences dozens of earthquakes large enough to be detected and thousands of smaller ones that most people never feel. According to the US Geological Survey, around 20,000 earthquakes are located each year using modern monitoring systems. That averages roughly 55 earthquakes every day. Most are harmless and occur far from populated areas. So, why does it suddenly feel like earthquakes are happening everywhere? One reason is technology. Today's seismic network is far more advanced than it was decades ago. Thousands of highly sensitive instruments constantly monitor the Earth's crust. Satellites, underwater sensors, and improved communications allow earthquakes to be detected and reported within minutes. Many smaller earthquakes that would have gone unnoticed years ago are now instantly displayed on public maps. Another reason is human attention. When one large earthquake makes international headlines, people begin checking earthquake maps more often. Then they notice every new event that appears. This creates the impression that earthquakes are accelerating, even if global seismic activity remains within its normal range. Scientists have studied this question for decades. Their conclusion is surprisingly reassuring. Temporary periods with more earthquakes or fewer earthquakes are completely normal. They do not automatically mean that a catastrophic global event is approaching. Historical records show that the annual number of major earthquakes naturally rises and falls over time. Some years exceed the long-term average, while others remain well below it. Still, researchers never ignore unusual patterns. They continuously monitor earthquake clusters, aftershock sequences, and stress changes along active faults. Every new earthquake provides valuable information about how tectonic plates interact deep beneath the surface. That data helps improve hazard assessments, even though no scientist can accurately predict the exact time and location of a future major earthquake. And that brings us to the biggest mystery. If more earthquakes do not necessarily mean greater danger, why are scientists paying such close attention to certain earthquake clusters while treating others as completely routine. Because what they discovered next was not simply about how many earthquakes occur, it was about where they happen. Because earthquake clusters reveal something far more important than the total number of earthquakes. 100 earthquakes scattered across different continents may be completely unrelated, but several earthquakes occurring on the same fault system within a short period can provide scientists with valuable clues about how stress is moving through the Earth's crust. That is why location often matters more than the number itself. History offers a remarkable example. In 2019, Southern California experienced what became known as the Ridgecrest earthquake sequence. It began with a magnitude 6.4 earthquake. Many people believed the worst had already passed. Less than 34 hours later, an even stronger magnitude 7.1 earthquake struck the same region. Thousands of aftershocks followed over the next weeks. Scientists carefully analyzed every new tremor because each one revealed how stress was redistributing along nearby faults. Yet, even during that sequence, no one could predict exactly when or where the largest earthquake would occur. This is where one of the biggest myths about earthquakes appears. Many people believe that if several earthquakes happen close together, a giant earthquake must be coming next. Others believe the opposite, that many small earthquakes release pressure and prevent a larger one. Unfortunately, neither belief is universally true. Every fault system behaves differently. Some earthquake swarms fade away without producing any significant event. Others become aftershock sequences following a major rupture. And in rare cases, what first appears to be a moderate earthquake later turns out to have been a foreshock before something larger. Scientists can estimate probabilities, but they cannot determine the exact outcome in advance. That is why organizations such as the USGS make an important distinction between prediction and forecasting. Prediction would require knowing the exact place, exact time, and exact magnitude of a future earthquake. No scientific organization has achieved that. Forecasting is different. Researchers analyze decades of historical records, fault movement, GPS measurements, and ongoing seismic activity to estimate the probability that a damaging earthquake could occur in a certain region over months, years, or even decades. Those forecasts help engineers improve building standards and help emergency agencies prepare communities. So, what should we expect in the coming weeks? The answer is surprisingly simple. Earthquakes will continue to occur every day, just as they always have. Active plate boundaries, such as the Pacific Ring of Fire, will remain the most closely watched regions because they naturally generate the majority of the world's strongest earthquakes. Monitoring networks will continue tracking every significant event in real time, searching for patterns that improve future hazard assessments. But if someone claims they know the exact date of the next devastating earthquake, that claim is not supported by modern science. The recent earthquake activity reminds us of something both humbling and reassuring. Our planet is constantly moving beneath our feet. That movement is not a sign that the world is ending. It is simply how Earth has worked for billions of years. The real lesson is not to live in fear of every new earthquake alert. It is to understand the science, prepare responsibly, and rely on verified information instead of rumors. Knowledge will never stop earthquakes, but it can reduce their impact and save lives. Thank you for watching. If you enjoy evidence-based explanations of earthquakes, solar storms, extreme weather, and other natural phenomena, subscribe to the channel, and join me for future updates. I'll continue following these events and bringing you the facts as new information becomes available.